All right. I'd like to welcome our live audience, as well as the people who are going to be joining us remotely. So. All right, everybody. My name is Everett of Project Babbage. I want to welcome you to the second day of the sCrypt Hackathon. I'm going to be joining you for the first little segment here as everybody kind of comes together and starts to join us on the live stream mainly. We'll be getting started with our first presentation in about 10-15 minutes with Jake Jones, so we got a nice one to start out with. Really looking forward to that. Yesterday we had some really great engagement. I think we had 3,000 people at one point watching live, mainly on CoinGeek on Twitter. But be sure to share this link, this live stream, to everybody, so that we can get some people on board. We have a really good lineup for today. We have Jake Jones, then we have Kurt in the morning, and then later on we have Thomas Giacomo, and then we also have a panel and a couple of other things going on later in the afternoon. So really looking forward to that. Like I said, feel free in the live audience here to kind of continue to mingle among yourselves. We're going to be getting started in about 5-10 minutes. Just kind of bringing in the live, or the stream audience rather, as we talk about some of these things. We've got a lot of things to look forward to in this ecosystem, and as I said yesterday, striking the balance between, of course, the enterprise adoption that BSV stands for, and then also letting people come in with new projects and new ideas, and giving them a platform to express those and present those. So it's really cool. I love the energy of this place. A lot of us here in San Francisco really enjoyed going to that restaurant for dinner last night. We had some really great food and had some good interaction there, and a really great opportunity to network. And I'm really excited to see more opportunities for the BSV ecosystem to come together, to network, and to really just kind of put our heads together. I was talking had a great conversation with David Case yesterday, and just kind of about some wallet stuff, and how can we bridge some gaps here, and I always enjoy connecting those dots and connecting with different people in our ecosystem, and I think that's what this is about. So if you're watching through the live stream, you should let people know we're going to be starting in just a few minutes with a presentation about Teranode, and so that's going to be really cool. I'm really looking forward to it, and yeah, there's a few core things in Bitcoin that are necessary. One of them is massive scalability. Another one is community engagement and getting new people with new ideas, building things, and getting really excited about what's here today. And then long-term thinking for tomorrow. And I think we have all of that energy at this event. I mean, we have people who would voluntarily call themselves, as I said yesterday, the degens of this space, who are just here in the moment, building things for right now, and just coding up something that takes a weekend or just a few hours, and then releasing it, on Ordinals, on BSV20 or BSV21. And then we have some people who are here for the grand vision of like the next few decades and bringing in that massive scalability and that enterprise and government adoption. And there's a lot of really great things that come from that. So to everybody who is here, wherever you are in this space, wherever you are on that spectrum of I want to build something for the next few decades to I want to build something really cool right now and make it memeable, right? It's all necessary. So I just want to maybe have some kind of recognition for these people. Like we're all here for the right reasons, and now I think more than ever, building and showing, this is what it's about: creating value and making sure that things are going to be scalable and sustainable for the long term, right? So, moving into our first little presentation here with Jake, we're going to need to have a network that can support all of this stuff, whether it's something like the next Ordinals protocol or something like what we've been talking to enterprise and government clients about. So the Teranode project has had some really great success recently, and I'll let Jake talk more about that. But the long and short is 1 million TPS. That's pretty crazy. So I think those numbers speak for themselves, and I'd like you to give a warm welcome for Jake Jones, and I'll let him speak to Teranode and some of the progress we've been making. So give it up for Jake. You're live. You can just click that on.
Okay. Thank you, Ty. And I'd just like to say thank you to Xiaohui and the sCrypt team at Ty and Babbage for putting on this amazing event at the historic Fairmont in San Francisco. Pretty amazing venue, and the atmosphere, as Ty was talking about, is second to none. So my talk today, Teranode, overlays, and the blockchain mandala. The blockchain mandala is the mandala is a term, it's been talked about previously, but we were in a meeting the other day and Thomas brought it up, and I thought it's a great word to use to describe really what the blockchain thesis is, where we're looking at how do we empower individuals to do things person to person as opposed to centralizing them and having to go through trusted entities. Is there a clicker here, Ty?
Yes.
Oh.
It's coming through the speaker. No, it's not muted.
Yeah, it's good now.
It's good now? Okay. So just a quick question. What do you guys think BSV's competitive advantage is? Just shout something out. First, I like micropayments. That was the first answer. Yeah, so BSV's competitive advantage is micropayments. That did not fit very well there. But It's actually in the white paper, small casual payments. So the whole idea behind BSV is empowering people to make small casual payments to each other. And apologies, that says unbounded scaling, specialization, and P2P communication at the bottom. Those are the 3 ingredients you need for micropayments. But if we look at the current model that we're using with SV node, we really only have 2 layers. So we have applications and mining nodes. We're missing a 3rd layer that allows us to separate out the functionality of nodes and applications. And so we're missing specialization. We're also missing SPV, although it is starting to come around now, but still very limited. And as a result, we have no unbounded scaling. So this is what we need to get to. And this is what Teranode has started. So Teranode is the nucleus, it's modular, and it's the model for pushing out into overlays and eventually into SPV wallets and applications. So we're trying to aim for a network that's fully peer-to-peer, specialized, and it's highly scalable, unbounded, and performant. Standardized APIs as well. Ty talked about that yesterday. The more standardized the interfaces we have to interact with different applications, the better, because then your private data, your data can be used with any application. It doesn't matter which application you're using. So jumping into Teranode now. Is this the, sorry, it looks like some things didn't copy over properly. I used a template. Anyways, okay, so here's an overview of the Teranode system. You have the UBSV node system. The UBSV is the internal name for Teranode, if anybody isn't aware of that yet. And so what Teranode is responsible for is maintaining the blockchain. That includes ordering and time-stamping transactions into blocks, and then it competes to add blocks to the chain. And that's all it does. It does nothing else than that, and that's how we initially enable the specialization and the scaling. So then it's receiving things from other miners, from other UBSV nodes, and that's just put there to show you that it will be able to interact with SV node, but it's using an overlay service to do that. And so here's the overview of the architecture. So it starts out, transactions come in at the top there through the propagation service. The propagation service feeds the transaction validator service, which is parallelized. So you have lots of transaction validators. They then validate the transaction and they store the metadata of it. Once the transaction is validated, it becomes blessed. And only the transaction ID needs to be passed going forward, which is then passed to the block assembly and included into a subtree and communicated to all the other nodes on the network until a block is found. And a subtree is what makes up a block. And so I'll go into the next section to describe a little bit more detail on what I mean by that. But that's kind of the gist of it. So it's just a zoomed in version here. We have the propagation service, the transaction validator, the block assembly, and then we have our store on the left-hand side there for our transaction store. And right now in the test, one of the requirements we have is to store transactions. So we are using that transaction store, but in operation, it's very likely that the nodes will not be storing transactions. So that's going to be up to the overlays and the wallets to keep track of. So block assembly, we have our subtrees. The subtrees go to the block validator. The UTXO store obviously has to get updated as well. So there's a UTXO store which stores and tracks all of the UTXOs. That gets updated when a transaction is validated. It also gets updated when a block is found. And the other cool part about this, I'll touch on this a little bit more, is in the next section, but we can make the assumption that the transactions coming into the network, pretty much all of the nodes are going to have roughly the same transaction makeup. So the synchronization is already kind of built in. And that's further improved by using something like IPv6 multicast. So here's the workflow. Submit a transaction, gets broadcasted, validated, verified, et cetera, et cetera. I don't know if you guys can see that very well.
We can see there's things that happen.
Yeah. The transaction status gets updated. Okay. We'll jump into subtrees because we can get into a little bit more detail. So the whole idea behind Merkle subtrees is we all know that Merkle trees are used in blocks where you have the Merkle root at the top, and the Merkle root is a hash, and all of the nodes that are going down from the root are hashes until you get to the bottom leaf nodes, which are the transaction IDs themselves. And what that means is you can carve out subtrees from the Merkle trees, and they're kind of interchangeable. The one caveat is they do have to be a power of 2, and the way Teranode works right now is it uses subtrees to a maximum size of 1 million transaction IDs. So here's the format. You can see transaction IDs. This is making up the subtree. And then here's the block, which is made up of subtree IDs. So if I just go back, if you look at these triangles here with the green hashes in them, these are all subtrees, for example. And then all you need is that top hash to be communicated to then make up the rest of the block, Merkle tree. Does that make sense? And here's a breakdown of the structure. And then the workflow again, just taking you through the subtree. So you see it's kind of the 4th or 5th line down there. You organize the transactions into a subtree, and then those transactions, those subtrees are communicated almost every second. So if we think about 1 million transactions per second, those subtrees are being communicated basically every second to all of the other nodes of the network. And that's where the real innovation of Teranode is, because we're taking a proactive approach. So instead of waiting for a block to be found and validating everything once that block is found, we're continuously validating as we go along. So that when a block is found, all of that information is basically already found, already validated. The nodes basically already have it. They just need to do a really quick check, and they can start building on the next block. This is just looking at the ingress, the egress. I'm realizing now that maybe this is a little bit too detailed. Here's the block assembly service. You can see the block assembler is sitting inside, and it's receiving TX IDs via either gRPC or RPC from the validator. But the test is now using Kafka, a message bus, kind of in between there. So you can do it either way, but obviously if you're running in production, you probably want to use a message bus so that you don't lose information, and you can load balance much more easily. And then it's pushing to those stores and getting information from the stores. So maybe this one's a little bit more visible. So this is receiving transactions from the TX validator service. We're adding it to the subtree. That subtree is being communicated to all the other nodes. And then on the receiving end, the block validation service. So this is receiving the subtrees for validation. The other innovation that's being used in Teranode, it's also being used in Arc, is extended format transactions.
Don't mind us.
Okay. What's going on?
I'm going to make it so it's a little bit easier to see.
Ah, gotcha. So extended format transactions are essentially transactions. They're marked in a second field there saying that they are extended format, and then the input information is just added or packaged into the transaction so that you don't have to go search up that input information. It just packages everything nicely together, so it's all in one package when you receive it. That's also part of the optimizations that are being used in Teranode. So I'll just skip ahead then to Arc and overlays.
Can I ask a question?
Yeah. Feel free to ask any questions as we go along.
Check. You go.
Yeah, very cool. I think I just try to understand how a wide subtree helps the, let's say, Teranode to scale. I don't quite. My guess is somehow enables parallel processing. Is that? Can you talk a little bit about the core idea, the high level? I know this is a lot of detail, but what is the high level that's the biggest challenge that's overcome? I think that would be very interesting to hear. Thank you.
Yeah, the basic concept behind it is instead of waiting and doing everything all at once, which requires a lot of resources, especially when you're talking about the scale that we're talking about, we're doing something continuously. So we're not waiting for that time to elapse. We're doing something every second, and that's being done in parallel by each of the nodes.
So, which is impossible to do without subtree? Is that? Or very hard to do without subtree?
Very hard to do without subtrees. Very expensive.
Okay.
Yeah.
And is subtree part of the pattern we're talking about, or?
Subtrees are an idea that come from Craig.
Okay.
They aren't directly in the IDMin patents, but they are a concept that comes from Craig, and they are in an N-chain patent.
All right. Thank you.
For sure.
Any other question?
If every node is creating its own subtrees, how do the nodes decide which subtrees to, or do they just process them all and validate them all, and then whichever block wins, that becomes the authoritative one?
Exactly. Yeah, they just process all of them.
So it's really just a matter of calculating the Merkle root for each one, and then you don't have to, because all the transactions are already blessed, essentially.
Exactly.
Cool.
Yeah. Doing things once instead of having to repeat the work. Any more questions? Those are good questions.
Press and hold?
No.
Hello?
Yeah.
Okay. So conceptually, the checking things once and never again is seems really obvious 15 years on. But I think the response would be, just to play devil's advocate, what are the risks of not double checking various, all kinds of things, frankly. But we've received criticism, or some people have brought up criticisms about the architectural safety of doing things the way that it's sort of outlaid here. I'm wondering how much work has gone into, just, I guess, treating it like a penetration testing opportunity, like that kind of thing.
Yeah, no, it's a good question. It's a good point. Obviously, we're still early. We're still testing right now. So that's not something that a lot of time has been spent on. But if you look at how robust things like Kafka are, it's very small amount of data, that, if any, that's being lost, right? Not until you get to a really high scale. Thank you. Good question. Thanks, Kurt. So just jumping into Arc, I think everybody's kind of familiar with Arc. If you aren't, it's the transaction processor for Bitcoin. And the reason why I wanted to bring it up, the main reason why I wanted to bring it up is because it does use extended format transactions. So if you're running a Bitcoin business right now, and you want to future-proof yourself so that when Teranode hits mainnet and you hit the ground running, it's really good idea to start moving toward Arc and integrating Arc. We have found that it operates better than Mappy, and it uses the extended format transactions that Teranode understands. So you can just see comparing the left to the right here. So this is, the left side is submitting transactions in standard format. You can see how many more steps it takes than submitting transactions in extended format. And so this is the architecture of Arc. It's pretty straightforward. You have the API, which can be used to submit things. And then you have Metamorph, which basically manages transactions and resubmitting them if necessary. And then BlockTX, which is receiving things from the node. And this is one of the main parts that obviously needs to be updated once Teranode is in place and we start using things like overlays. And so that's really all I wanted to show. So just remember those last few images. And if we get into overlays, this is, again, kind of coming from the design of Teranode. So Teranode timestamps transactions into blocks. That's all it does. So all of the stuff that the node used to do now has to be pushed out into overlays. So an overlay, there's a few different definitions, but most people understand it as basically a layer that sits on top of some other information layer that provides new insight into that information. So in Bitcoin, an overlay operates on top of the node network in a way. So you can do things like look up transactions, token management, open predicates. But I would say one other thing to add here would just be it manages things based on transaction types or transaction templates. So this is a nice visual here. These slides were put together by Dagan, by the way, the overlay ones, so thanks, Dagan. So if you look at this image here, this app is only interested in the yellow transactions. This is a block. The blue square here is a block, and then these yellow lines are transactions. And then you have another app that's only interested in the green transactions. And the red transactions include payment tokens that are used for both apps. So they have importance in both of the contexts. So overlays allow for all of these different contexts to talk to each other and intermingle with each other. Oh, that's too bad. There was a cool video. These pop up. But essentially what they do is they allow the P2P aspect of Bitcoin to take shape within all of the extra stuff that nodes offer that they no longer can offer because of scalability. So things like, again, looking up transactions, keeping state, all of that stuff. This is, I know we talked yesterday about having a debate about indexers too, but essentially what we could do is you could just take that indexer that you're using right now for the entire chain and put that into an overlay, and it just cares about those specific transactions. So kind of the best of both worlds if you wanted to approach things that way. So these are the features of an overlay: validation, maintenance. Yeah. Here we go. Let's look at some use cases. So fungible tokens, non-fungible tokens, open predicates. So that's the idea of having a transaction that's open that people can put their computation towards. data predicates, so the storage market. There's a concept that's been talked about quite a few times where you can set up kind of like a Merkle tree structure, a hash tree structure that enforces data storage for companies. So they only get paid if they store the data for a certain amount of time. There's backup services, explorers, etc., etc. So this is what is needed today in order to start using overlays. We have SPV wallet users, inbound transactions, so then we're submitting those to an API. And then we have the block header service. What we don't have is looking up UTXOs, and then also a syncing mechanism down there. You see the orange squares. But we do have a token validator, and we do have the UTXO and Merkle path stores. What we would like to do in the future is integrate, basically integrate IPv6 with this stuff. So IPv6 multicast, where you can then broadcast these to specific groups, and you can do that within the overlay as well. So I feel like the slides were kind of too small and not really super helpful, so last couple and then open it up for a discussion. So if you remember the architecture image from Arc, basically what I've done here is I've replaced the couple pieces that would need to be replaced in order to move this into an overlay structure. So instead of getting information from the node, the information is coming in through Arc, it's being stored within Arc and managed within Arc, and then it's being time-stamped onto the main node network from Arc. And again, in future, we could use multicast groups to do this. So thank you. Let's open it up for discussion.
So on the extended format, the input scripts and input satoshis are obviously embedded in the transaction. At what point of the flow between broadcasting to Arc to broadcasting to Teranode to whatever, does it actually verify that that's the real script and the real Satoshi value? And because obviously there's an incurred cost of having to look up a UTXO set. Where in the whole flow does that happen? And is it just like a hash of those values is how they're identified, so you know that you have the right one, and it just does this exist or not? Or just kind of how did that process work of going from the extended to the
let me just try and get
actual data
to Arc. I don't know if this is going to help at all. But Teranode doesn't actually change the transactions into extended format. That's done by Arc. So it's done at the Arc level. Right now, obviously it has to use the Bitcoin node to do that. It does a lookup and then changes that structure.
Yeah, I should say it the other way of when you submit them in with extended format, obviously you can validate the script looks right and that the transaction looks like it's right. But at what point do you know if those UTXOs, is it only really once you go to do a has this been spent yet check that you would actually find out that the UTXO they passed in wasn't a real UTXO?
I'm not understanding your question.
Okay, so in the extended format script, you've got the input or the previous output scripts and satoshis.
Okay.
There's nothing in Arc, I assume, necessarily that goes and makes sure that those are real or that those exist. And obviously, if they've already been spent, it wouldn't find them anyways. But Arc, at that point, has no reason to go say, okay, give me these old inputs because they came in an extended format. At what point in the mining process is it validated if those actually are real UTXOs? Is it just like if I would submit a UTXO that had already been spent in that, I just can't find this, and so therefore it's missing, therefore it's not a valid transaction? Or kind of where in the flow does that process happen?
In the validator, yeah.
So it's not in the blessing stage, it's actually in the later stage
No, it is in the blessing stage. So the transaction validator receives the transaction coming in, and then it does a check against the UTXO set and just establishes if it's a legitimate transaction, if it's valid. If it's not, it just rejects it. If it is, then it blesses it and adds the metadata to the metadata store and pushes the ID to the block assembly.
All right, cool, thanks.
For sure.
Right. So in that context, right, like with an SPV wallet, though, where I already had my previous transactions that I'm now spending. Right now, you talked about this intermediary step where, in order to get the extended format transaction, we have to use something like Arc to look up the previous output script and Satoshi value. But if we were using an SPV architecture, right, in the long term, maybe can you elaborate on how that might work differently if users were actually just, like tracking this directly? Would that reduce the computational load that everyone needs to perform on behalf of users if the users kind of kept track of that themselves inside of like wallets?
For sure, yeah, it definitely could. I guess it would be up to the application developer how they want to do it, but
right.
You could have most of that state being stored in the wallet, and then you're running an SPV check, a Merkle proof on the received transactions to do that verification at that level, and that is like a preliminary verification, and then you can do another check at the overlay level.
Right.
Yeah, or you could do everything at the overlay level.
Right, well, because if I'm a user and I received a transaction from somewhere, right, like someone sent me a transaction, and now I want to spend my coins, I would have already received the necessary information, right? So it's like, why would I throw that away and then have to have someone else, like Arc, for example, have to go look all of that up again when I might as well just, keep track of it in the same way that I keep track of the fact of my owning those particular Satoshis or those particular UTXOs to begin with.
Exactly, yeah, that's the end goal, is to track as much of this stuff at the edge as possible.
Yeah, move it all out to the edges.
Yep. Thanks, Ty.
Other questions for Jay?
Okay, speaking of edges, I think we talked about yesterday, maybe we should have to spice up a little bit about indexer and overlays. Just to me, I think about overlay is like also in the mandala graph, right? So they are kind of like concentric circles, and the overlay is almost like the inner core is the mining network, miners, and then the first layer, the second layer. Where is the overlay? Is it anything that's above the inner circle? Is that about right?
Yeah, I wonder if I can get back to that diagram so I can show you. But obviously Teranode is at the center, and then in this second layer there's likely going to be something like a specialized node that's assisting Teranode in some kind of mining activity. And then the layer after that would be where the overlays mostly live. And it'll be the overlays that are talking to Teranode or even integrating with Teranode in some respects. And the outer layer is obviously the wallets, applications, that kind of thing.
Okay, so in my understanding, in this setup, still doesn't matter which layer you are in, you can still, if you want to, you can still directly broadcast to the miner. Let's say wallet.
You can, but the thing about it is, most of the time you're going to be using transactions to accomplish something. Like you're likely not going to be just sending plain Bitcoin to people most of the time. You have a transaction type or transaction template that is going to activate some kind of service at the overlay level. And while you could send that transaction to the node network because it's ultimately Satoshis and the node would understand it and probably mine it as long as it's valid, you're going to miss out on accessing the service that you want to use because you haven't sent it to the overlay first.
So I think in some of the circle we're debating, of course, if you talk about incentive, of course you are incentivized not to broadcast directly. But what if, let's say that's an attacker, he just want to, create havoc. Is anything, we talk about this, heavily in our chat. Is anything that's, let's say, how to prevent such kind of attacks?
Just,
of course, that regular users, they should be incentivized. But what if that's, malicious user? He just want to cause trouble. Is there anything you don't want to? I heard some TDXP or some app that's some people they just directly broadcast to the miners, causing the apps to malfunction. How do we stop this kind of? Is it not possible technically or?
Yeah, well, the one thing that comes to mind is maybe using something like a version in the transaction, and so you're using, or maybe you're using some kind of format that is invalid. So if it gets sent to the nodes, it gets rejected. But if it gets sent to the overlay understands that invalid format, and then if you're using something maybe like say cache flags, it can update the structure of the transaction and fix it and make those adjustments so that it's a valid transaction again, and then submit it for you.
Okay. So last question. So once we get to 1 million transactions per second, is any, let's say, blocker to reach 10 million, 100 million? Is it we have to totally, it's like from SV node to Teranode, and then we need another huge leap forward, or is this just horizontally scale? We just add more machines.
Well, hats off to Siggy, Simon, Liam, and the rest of the team for all the development work that they're doing on it. But for the most part, it's horizontally scalable now. The only part that isn't, that needs to be worked on, is the block assembly. That's still one system, and it's limited by the subtrees being 1 million transactions per tree, and the way the subtrees have to be split up. So it becomes a bottleneck because you can't have different size subtrees coming in. You have to wait for them to fill up to a certain amount, right?
Okay. All right. Congrats. Thank you.
Thanks.
Other questions for no?
Good morning. I wanted to follow up on his question. So if the test node is 1 million transactions a second now, right? Where and when do you think we'll get to the next level where like it's 1 billion, like where Craig Wright was talking, like where it comes and we can really start using micropayments everywhere? Like are we 6 months away, a year away? Do you have any idea about that?
Well, I would say once Teranode is on mainnet, we're good to go in that respect, because 1 million transactions a second is a lot.
It is. And when is that projected to be?
At the end of this year. So
at the end of this
next year is the goal is to have the alpha on mainnet.
And where are we at right now? How many transactions can we do today that's not on the mainnet?
They've tested 2.3, I think, 2.3 million.
And that's on the Teranode, right?
Yeah.
Where are we at today on the live chain?
Oh, on SV node, I think it maxes out at about 5,000.
5,000 today. Okay. Thank you.
Extended periods with less than that, it can still affect everyone else's experience on the network.
Yeah, there's lots of variables to answer that question.
The absolute theoretical maximum, I think, is about 5K though.
All right.
Answer when you think this would be effective.
Yeah, the aim is to have it testing. Well, we want to test on mainnet as soon as possible. So during the development process, have a listening node that's getting transactions in from the main network. But the goal is to have an alpha version on mainnet at the beginning of next year.
And then I have another question, which is, what are the funding requirements to get there? And is there any risk of that funding drying up before production is realized? That's sort of like a risk that I see in my head.
Yeah, no, it's we're not aware of any risk. It's fairly significant amount of funding, but haven't heard anything negative from that in that respect. So.
Funding that's committed, or do you already have funding?
Well, the budget for this year is committed. Yeah.
So don't sell.
Slap it up. Slap it up. I guess I realize that there's still other pieces of the stack that are not filled out yet, but obviously if Teranode does not archive transactions, there's a real risk of having it to a point where no node can actually sync back up and join the chain without having a trusted UTXO set from someone else. I guess I wonder how much from BSV Association is being thought about just for the sake of the network, like someone has got to, at least for a period of time, maintain these things until some sort of UTXO commitments or something else can be come up with that can have a trustable UTXO set. Yeah, just kind of curious how highly that's, or how much that's been thought about to this point, and if there's a path moving forward to address that.
Yeah, no, that's a really good question. Thanks.
Gorilla Pool is going to be selling synced disk images for millions of dollars.
Nice. Good business model. But yeah, it is something that we've been thinking about, and so it would be the association that hosts some kind of bootstrap service that nodes can tap into if they need it. But most of the transactions and UTXOs will hopefully or ideally be just gotten on the fly. So when they join the network, transactions are coming in, they start getting transactions. If they need them, they request them from the other nodes on the network.
So that makes sense. So if someone puts a transaction into a block, they obviously have, yeah, sorry. I was just going to acknowledge, I guess that makes sense, that if someone puts a transaction into a block and no one else has that UTXO anymore, I guess they're going to have to provide that transaction or no one's going to build on top of their block, and so it kind of solves itself. Right. You don't have to worry about, okay, I don't have these historical UTXOs, because if someone's going to put them in there, they're going to provide them.
Yeah.
I guess, how do you know if they're valid or not? Without, yeah. Obviously, this is the problem, a commitment of some sort.
Yeah, and it's definitely something that we've thought about or been thinking about, and it would be the association that hosts something that helps bootstrap. Any more questions?
All right. Thank you, Jake Jones.
Awesome. Thanks, guys.
All right, everybody. It was a great presentation by Jake Jones. We're going to be starting up in just a few more minutes with Kurt Wuckert of Gorilla Pool, talking about JungleBus and some other things. Before we do that, I think we're going to just have a short break. So we'll be right back in just a few minutes for the next presenter, which is going to be Kurt of Gorilla Pool. Thank you. All right, everybody. In the next couple minutes, we're going to start to come back here. We're going to be coming back with a presentation by Kurt Wuckert of Gorilla Pool in just a couple minutes. All right, guys, as we approach the top of the hour, let's kind of come back in here for our next presentation by Kurt Wuckert. Last we had Jake Jones up here and talking about scalability and the way to achieve scalability. But of course, we need a node software, right? We also need some Bitcoin miners. Some mining pools. Gorilla Pool. So, the scalability of Bitcoin is important, and I'm very interested to hear what a fellow miner, well, I'm not a miner, but what one of the Bitcoin miners has to say about this topic, and so looking forward to a great presentation by Kurt Wuckert, talking about JungleBus. So please give him a warm welcome. Here's Kurt.
Thank you, Ty. Very, very kind of all of you. Thank you. I'm going to hold the dead cat. So, how's everybody doing? All right, so I will be talking about sort of the network generally, like nodes, node operation, but then our product, JungleBus, which is designed to essentially bridge the gap between your infrastructure only people and your service providers. So we are what I like to call a how do I switch forward? Is the click this thing?
Should be, but
it doesn't appear to be.
Doing the same thing again. Let's give the window focus. Oh no.
Ooh, you're good.
Let's see. Oops. Try now. Yeah.
Cool.
Is it working?
Ooh, I forgot I had effects on this. I made this slideshow a while ago. All right, so I'll talk a little bit generically about Bitcoin and the network generally. People still, outside of this room, I'd say there's probably less than 500 people on Earth that have any idea like how Bitcoin works or how it could work or thinking in ways that could bring it into the future. I've been hosting meetups and stuff in the Bitcoin space for, 7-8 years, maybe even a little more. And most people barely get past your basics on anything. And so the number of people that start to think creatively and therefore can start to think fractally about how Bitcoin can work is infinitesimally small. I'm not going to be so crass as to read all of this, but for anybody watching, this is a decent read, I suppose, but kind of explaining the marriage of data and money. To your typical BSV crowd, this is not going to be new or particularly enlightening here on this slide, but ultimately it is a both and. Just as much as money is data or is a measuring stick about data about people, well, data is itself also money. It is the rarest commodity and it is the most abundant commodity and it is the most valuable commodity, and it is the most undervalued commodity, all at the same time. And so if you are ignoring the power of data from a value creation, extraction, any perspective, you are underestimating the value of data. And Bitcoin allows us to attach value to every single bit and byte of data on Earth, which is itself, it's an incalculably valuable opportunity. Here's the Bitcoin white paper and a monkey. So what is Bitcoin mining? Let's talk a little bit about what the infrastructure actually looks like in Bitcoin, right? So your wallet, either your the sending wallet or the receiving wallet, it's incumbent upon one of those things to get that transaction to the network. Now there are a few ways to do this. Typically this is just done by API, or it's done directly onto the node of a wallet service provider. So your Exodus wallet or Edge wallet or any of these like multi-coin wallets you might be used to, they are running a full node for every chain they operate. They have RPC access to that thing. They send transactions to their node. That works just fine on every network except for BSV because, well, BSV has too much going on, and everybody wants to run it on a relatively small and relatively underpowered system, and then it just doesn't work very well. So. But in a basic sense, that's what wallets are doing. Now those nodes then gather transactions, and then they are validating transactions before they are mined into a block. But every node on the network should at least be attempting, if it's connected to the network at all, should be attempting to validate transactions as they arrive. Now that opportunity for them to validate before blocks are mined, this is what we frequently think of as the mempool, or call the mempool. It is typically in memory, although it doesn't necessarily have to be, but right now this is how it works. Now, at the same time, the one aspect of Bitcoin mining that has been specialized out is your ASIC hashing. So you have your ASIC machines right now that are working on a brute force of a list that the network has generated based on current difficulty, and it's doing a side pot, but the side pot is designed to let you know that you can trust the block if you mine the block. It's the proof of work. So if anybody tells you that ASICs are solving complex math problems, stop listening to them. It is the most frequently said thing that is false in the Bitcoin space. It is simply doing a guess and check on a list of hashes, and is looking for the first possible hash that it can find that has a sufficient number of leading zeros. And if it does that, then the proposed block template that your node has provided then is proposed to the network and saying, we think we're the chain tip, our proof of work is sufficient, and we think you should build on our block. That's it. So that's what's happening there. Now, reconcile block, if accepted, all nodes, or the node that gets 100 blocks later, you get paid for the block that you proposed, if it's accepted, et cetera, et cetera. So I can go into more mining 101 if you'd like. So this is the network, sort of, as it looks right now. Okay, it is actually an exaggeration in many ways, but that's fine. Analogies are never perfect. So let's assume that near the center, these are your mining nodes, and then you can see edge computers or edge systems that are, these are your wallets, various other service providers, people that are connecting to the network in some way. Inside the circle, that would be a mining operation. So this is full node operation, ASICs, and then you have people that can join that pool. I have below that, so these are your people that just want to quote unquote mine, but they're not really mining, they're just providing hash to a mining operation. And that's really what the network looks like today. Kind of chaotic, right? Like if you look at the pattern, it's a very chaotic style network because we're still not very closely connected, which is why, Jake is talking about 1 million TPS, but when it's like, well, how many can we do today? And it's like, I don't know, like 5,000 TPS, which isn't that impressive. And part of that is because incentives are poorly aligned. There's actually not a lot of opportunity on the network yet, despite all of us saying it is a multi-trillion-dollar opportunity. The day-to-day opportunity is not that big, and therefore it's not very well coordinated because economic incentives will give you exactly the amount of chaos you deserve. So now, on to this trillion megabytes of data created every day. So across everything you tweet, post, TikTok. I don't know how many people in here have OnlyFans accounts or whatever, but you guys are creating economically valuable, or in many cases not valuable, data. And so that's all being created. And right now, like the amount of data that is used in a blockchain scenario is so infinitesimally close to zero that it's frankly incalculable. And the reason for that is that the amount of total data is also almost incalculably large. So Bitcoin was initially designed to solve the problem of spam. It does this with proof of work. But we're not just focused on being a mining operation. This is where my presentation pivots from Bitcoin mining 101 and starts talking about what it means to be in the data space. Okay, mining is actually really easy, and there's a lot of people that are a lot better at mining as an industrial process than I am. So let's talk about big data. Your blockchain as a database, the database that runs on your quote-unquote full node, is an unsorted, monolithic, chaotic mess of data, because I can send you a pay to public key hash transaction, or I can send you some kind of pay to this script, pay to an sCrypt contract, pay to whatever, pay to hold a locker, or pay to do whatever other nonsense I want to do, or maybe I just want my whole JPEG collection on chain, but there's nothing forcing me to get in line in order to do things in a way that is pre-sorted or has any logic outside of the chaos of just an open economy. And therefore, as things get written to the chain, they are written in, it's like taking one teardrop out of the ocean, right? It's like, hey, where's my data that I threw in here, right? Well, that's a massive sorting problem. If anybody's aware of the problems of sorting, well, you've actually started one of the first conversations about what an algorithm even is, or what it does, and why hashing exists, and all of that. But so we worked on this problem for some time. In fact, we've seen solutions to this in the past. Many of you recall, the Planaria stack from Unwriter, or things like Matter. Matter Cloud from guys like Attila, and probably for a time close to a dozen other options for those kind of API access to blockchain data. But all they were doing was creating some very simple filtering options and connecting it to their full node, which isn't really a profitable business model, and that's why everyone you've seen in the past has now disappeared, frankly. So your options today really are Gorilla Pool's APIs, primarily JungleBus, and what's on chain. And I think Tal offers basically RPC access to their node as well for people that just want node data. But what we've done, JungleBus is not, so people will say, well, it's an indexer, and it's like kind of true, but it's much more of a highly specialized node implementation. So it doesn't build blocks. So it doesn't do anything that it doesn't have to do. But what it does do is it listens to the network like any other node would. It is sorting things into preconceived buckets as it comes off of the network. And internally, we actually call it an overlay network engine. So it is a little bit of a both and from a future of Bitcoin standpoint, in that as it listens to the network, it'll listen for things like single sat outputs. And then if it's a single sat output, it will see, well, is it a one sat ordinal token? And if it is a one sat ordinal token, we will filter it into that bucket. And so while the Bitcoin node is this monolithic database, JungleBus is sitting and doing the heavy lifting on, okay, what's what? and let's give it to the people that need it. Now, if you need any kind of data, if you just want to filter for JPEGs, or if you just want to filter for JPEGs that have cats in them, or if you want to filter for tokens that are JPEGs and are compliant with various types of contracts, or you can just filter for things that are compliant with certain sCrypt contracts or whatever. So just like many people have been saying for many, many years, you don't need to have everybody's data. You need your data, or your company's data, or your client's data. And then you can run your super lightweight index based on its connection to JungleBus. Now, JungleBus is not just an app sitting in the cloud somewhere. JungleBus actually has a massive hardware requirement. We designed this thing from the ground up, and I don't know if I've ever talked about this publicly, but the architect that helped us put this all together is the current lead architect of Teranode. And so JungleBus was actually built as a proxy to kind of bridge the SV node era into the Teranode era. And as such, again, it's not just a floating piece of software. It is itself kind of an analog to the future of node operation fundamentally. So I'm talking over my own slide before I even knew I switched it, but it's a good thing I have everything memorized. So yeah, basically it's our one bit of our proprietary stack, and with that we allow you anybody. It's currently free and public, so anybody who wants to subscribe to any data in order to feed your app, if you're currently running a node and you like to operate with RPC, just give it a try. It can just give you various UTXOs and give you UTXOs and Merkle proofs. It can give you anything you want. We have lots of filtering options for whatever it is you might be using a node for. And since right now it is literally free, I guarantee you I will be saving you money if you are running a Bitcoin application that uses a node. So you're welcome. And so moving forward, let's talk about what an overlay network is and what it does or what it can do, because right now we don't use them for much of anything. If anybody's using them at all, it's probably in pretty quiet commercial application. Now, Ty's a good example, the Babbage stuff, and one-set ordinals. Like those are the two primary overlay networks that are working at all in BSV. But volume is still relatively low, so we're not really testing. It's like we have a $1 million race car, but everybody's doing 30 miles an hour around the track, and like, okay, like steering appears to work. That's all good, but ultimately we want to try to get the wheels to spin off the damn thing so that we know what we need to re-engineer. So your overlay network, what it's doing is it is allowing you to take one step up above the Bitcoin node network, which in many cases nobody needs to be interacting with. The infrastructure players can interact with each other. We have every incentive to have gigantic tubes that connect us, for lack of a better analogy. But if you're just trying to send a simple payment, or maybe you'd like to make 5 or 50 or 500 token trades a day on onesetordinals.com or where Firesat or wherever you're at, you only need to be operating in the ecosystem you're operating, and that can be tangential. It's floating above the network, and it only connects to the network when absolutely necessary. And so, but they need a way to communicate it when it needs to settle, or when things need to be double checked. There needs to be a pathway to get back to Bitcoin, and JungleBus is that pathway. That's what we have built. We are in the early days of discussing how this will need to be not heavily re-engineered, but there will need to be some re-engineering in the Teranode era because there are some fundamental differences in the way that network will work from a topology standpoint, and the software is just plainly different. So, but again, because JungleBus was sort of conceived with the future in mind, and frankly implemented by the same people who are implementing Teranode, there's a lot of it's like cousins meeting at the family reunion, and like, wow, we look kind of alike. So that's what that looks like. Now, how does Arc play into this? So we, as Gorilla Pool, we actually still have a MAPI endpoint up as well for anybody that wants to use it. It doesn't really get used very much anymore, but we haven't knocked it down because it's essentially free to be there. We use Arc. Arc is right now the best way to get transactions into Bitcoin, and then in my opinion, JungleBus is the best way to get data out of Bitcoin. And so if you can easily get stuff in and easily get stuff out and repurpose it, like remove all that friction to how the heck do I use Bitcoin at all, well then it should allow you to not have to have an infrastructural conversation about your own business. Now, the analogy that I like to use, I've used the word analogy like 4 times in this speech, and I apologize, but is imagine you open an office for your business. You do not have to figure out how to route the internet to your company in order for your company to connect. Well, sounds like I've struck a chord. Perhaps some of you have. And actually in this room, I wouldn't be surprised. There you go. I wouldn't be surprised if people here are like, well, I actually run my own ISP, but most people, you just call Comcast or Verizon or whoever and say, hey, give me the juice. Like, what is it? $500 a month? Cool. Here's my credit card, and that's how you connect to the internet, right? So that's the ISP model of business. We don't have to think more heavily about, okay, like this is going to take us 3 to 5 months. I mean, I need to sync my company to the internet. Like, there's none of this stuff, right? So I want you to think of Gorilla Pool's business model as that. As much as I would hate to compare us to Comcast, on the list for the most hated company in the world often enough, that's actually the business we're trying to recreate in a much better way for you. We want to be that Web3 ISP for your company in the blockchain space. So Arc is the way that you broadcast. JungleBus is the way you receive information that comes from the blockchain, or actually from the mempool or the blockchain. But anything on network you can receive through JungleBus. And then ultimately, those things, whatever you need. So up here we have the hat is for magic attribute protocol data. So it's a very simple data structure for you to put any data on the blockchain. I also have the run token logo up there because we made a second product called Jungle Run. I know there's been some concern that your run tokens are going away because run's been gone for 18 months or something, and various other people are shutting down wallets imminently and whatever. So hey, how am I going to get my run tokens? Well, we have a Jungle Run endpoint, which is basically the Run API, but using JungleBus as its engine. So if you need to get your run tokens, or if you want to have a wallet that will offer you an option to do anything with run and or OneSat, we offer full indexing support for all of that, and it's right now all free. And then we have the OneSat logo, the bullseye up there is the other thing we offer. So what we're doing is we are feeding indexes with our overlay engine, and it allows you to run your own index. So if you want to run a OneSat indexer, if you want to run or if you want to run a wallet or any of these other things, our docs are public. I should have it on the slide, but I'm a goofball. But you can go to junglebus.gorillapool.io. You can check out the docs. Docs are pretty good in my opinion, and if you have any questions, you can join our Discord. You can ask questions. You can actually, if you're here and want to ask questions, David has been helping us maintain it and has frankly brought us from V1.5 to JungleBus V3 over the last 9 months or so. And so any technical questions about the latest iteration of a lot of these endpoints and indexers and all this stuff, David's a really good guy to talk to. Or if you want to make a special deal and you're like, hey, I need some absurd amount of data connectivity, you can talk to me about how to set up business ops and that kind of thing. But we see it as our responsibility to provide you with tools that allows your business to get rid of as much infrastructure as you're comfortable getting rid of, and so you can just focus on your customers, your marketing, and your application. And I see a lot of some of my favorite app developers in the world in this room, so I would hope that we can help you be more successful, and ultimately I see us as all working for Bitcoin. And so if we can help each other bring it all up, then we're all better for it. So I don't know how I am on time, but do we have any questions?
You mentioned, Kurt, that we could run. If we wanted to run away from run, is this also possible? Could we build a bridge for these tokens that maybe you can access them and then transition over to another UTXO-based protocol? You could maybe have some kind of, I don't know, you'd have to depend on the token logic, right? But but could you create an OR condition where you're I want these transactions of this type, the run type, but then I also want to enable them to be spent and then transformed into another type of transactions. That way we can run away from run.
The simple answer is yes. Run is really powerful in a lot of ways, but it tries to simulate state, which is itself kind of a nightmare, and so they don't scale very well. But they are very cool, and I think are useful for a lot of use cases that can go into the future, just not any that need a lot of velocity. So the way I've sort of considered this in my head might be a cool way to reissue. So like I like the JPEGs and stuff. I have a lot of Gopniks and Slavets and stuff hiding in my wallets, and so I would love to be able to like lock to bridge. I think could be a really cool way to like say, okay, well here's the original token, and then new token sort of exists here. It was reissued there, and now it's on OneSat or STAS or whatever proprietary system you guys want to do. I think that could also be a really good way for a company to have a DEX that doesn't necessarily have to use the token protocol at the base layer, but your own interface can have its own very lightweight token structure. And then when you exit, you can use an unlocking script on the way out, and you can essentially reissue or unlock that asset back to your wallet, however you decide. That's not no engineering, but it seems like a pretty simple solution for a lot of these things. But so far there's not a David's shaking his head no, so he will not be building it. But yeah. Any others?
Yeah, sure. Just want to play devil advocate here. Okay. So in Bitcoin, when we scale, we always take the approach. Don't do everything. It's like I'm sending you a transaction, right? Mm-hmm. Every other blockchain is broadcasting to the miner, and then the receiver is just to scan the whole thing and then get it, right? Instead of I just hand you the transaction. So here, I don't know, is this my misunderstanding that the JungleBus kind of feel like, you got to scan the whole thing? I mean, I understand the miner because you have to do that anyway. Yeah. So is this an issue if, for us, we want to, let's say, run OneSat indexers, mm-hmm. Is it an issue, just depend on this kind of service? Because if it breaks, all the downstream stuff, indexers, sure. Apps, well, how do you address that?
You make a really good point, and it's funny because I think it's an interesting conversation to be a maximalist about, like everything peer-to-peer versus everything indexed, and I don't think that that's a dichotomy that actually exists. There are lots of things that make a lot of sense to keep outside of the node network, but there are other things that make a lot of sense to index. And for us, the way we see it is we have to have all the data anyways. That's our business model. And so repurposing that data that we are already paying to store and giving people access to that data in a way that is easy is just, it would seem silly not to do that, actually. And so now your question is, if you're running an indexer, so if you're running a OneSat indexer, yes. For example, and probably connected to JungleBus. Yes. So, but,
it's not 100% reliable, to be honest.
Yeah, no, for sure. Yes. And we know it's not 100% reliable, which is why it's still free. Like we're trying to engineer it in such a way that we can charge customers for it and have guaranteed uptime. Now we're pretty proud of the progress we've made, especially at some of the scale we've seen on the network. Like we've seen JungleBus ingest transactions at levels that are exponentially better than the SV node can, and so that's kind of our benchmark on needed reliability and scalability right now. But you're right. When we saw, for example, the stuff at Firesat, all of a sudden it was this massive UTXO set and all this other stuff, and like we were excited to see it. However, we were not excited that one week earlier there was 10 transactions per second, and then the week after it was this absurd UTXO set to calculate and all this other stuff. But it's that kind of thing that gives us the opportunity to re-engineer both. JungleBus got a pretty major update there, and so did the OneSat indexer. And so it just kind of gives us the opportunity to work on that stuff. So I encourage anybody in here, if you're scared to break the network, please keep trying to break the network, because that allows us to dig into our pockets or ask other people to say, hey, it would be a good time to fix these problems. But ultimately, yeah, we need to improve this product to where we get to that 99.69% uptime and reliability. Because in my opinion, indexing will never go away, because there are things that just require to be indexed in order to function. But lots of other things will get pushed off into overlay networks and a peer-to-peer structure, which is good because we don't want to be indexing terabytes of data every 10 minutes either, because that, then we're talking about like, do we need to buy Amazon in order to be a company? So, which I guess is a problem we'll make based on money in and money out. But I don't know if I fully answered your question, but I'm very happy to admit that we are not perfect yet, but are trying to iterate forward. And ultimately, we want our customers to be able to run hardware that perhaps connects directly, or maybe we make a relationship where you are subscribing to our internal, basically our internal implementation that is like physically connected to our node and those kind of things. So. For critical uptime stuff, it's kind of like how does AWS service like the NSA? It's like the NSA doesn't say, well, we need our own. They literally just make a special agreement with AWS to have specific uptime. So we'll
please
get there.
take our money, please.
Yes.
SLA, yes.
We will be very happy to take your money. We're trying to be worthy of it.
Yeah, thanks.
Yeah.
Quick anecdote. I think when the ruling is out the day, I think we're still, the DM, because we have some JungleBus issue, we're still debugging that. So just on that.
I think it's a testnet. Are we having a testnet issue
testnet
right now?
Yeah. So
testnet version is not one-to-one with mainnet, so we're working on that too.
Yeah, that's just let's say how the ruling is. Prod. Okay. Reverse. Yeah.
Yeah.
Yeah, that's kind of the let's give you a vibe. That's how much we care about the ruling or not. It's just we just need to get things still working regardless of the ruling or not.
Yeah, we have like a 5-year business plan, and we didn't ask Craig for permission to do that, so I'm not really worried about whatever he's up to. God bless him. I hope he's well, but our business plan doesn't change if he ends up being the next king of England or if he retires in an unnamed island somewhere. So it kind of is what it is. So, Jake?
As a node operator, and the experience you've gained over the years, and knowing what you know now, obviously talking to Siggy and everything that's developing with overlays and whatnot, what would you like to see first in that sphere kind of develop along with how the ecosystem develops, and where do you think is the place that people should focus their efforts?
Man, if I could create a magic wish list with a magic wand and $1 billion, so I've actually been an advocate privately and quietly and sometimes a little bit loudly that we need some kind of a bridge between SV node and Teranode. I think Teranode, especially 5 years ago, was it's cute. It looks great on a pitch deck and everything, but ultimately it's trying to solve a problem that might not even exist 20 years from now from a volume standpoint. And so to have something that is lighter weight, isn't so aggressively futuristic. I'd love to have something that just readily and simply does 50,000 TPS and is written in a language that is well known and can be serviced and whatever. And I would be happy to take whatever trade-offs are there to get there. And we've even looked at doing it internally. There were times when we were running a proprietary, we called it Gorilla Node internally, and we've reverted back to just using SV Node because as that progresses, then it's bugs and we're maintaining forks, and we just kind of don't have the manpower or the budget to keep doing that. But I think that would be a big one. I think also just kind of what I said before, we need more people that are trying to break the chain. I think we had a little bit of a back and forth with the FireSat people that I think both sides felt like was maybe contentious at different times, and some people throwing insults back and forth. But from my perspective as the CEO of Gorilla Pool, I was looking at it and saying, guys, I know we're all kind of irritated with each other, but 10x your volume from here. Keep breaking it. We will keep staying up late and deploying more resources to make this happen, because now we've got, for example, a paid indexer that is making us money based on FireSat, and that wasn't something we even had the incentive to build before they created that market. And so I've said it like a million times in the last 5 years. We need more people that are out there getting customers, because customers solve every problem. I don't have any reason to make this company any bigger with the few hundred or few thousand people that use BSV today. But if there were a few million people saying, hey, why doesn't my stuff work? Well, I mean, that allows me to raise more money. It allows me to hire more devs. All of that. So, from a software standpoint, like we already have the most performant network in the world, and we're trying to upgrade it into, again, like 20 years of future proofing. But how much of that money could be spent on client acquisition and stuff like that? So. Thanks, Jake.
Morning, Kurt. Thanks for your presentation. I have a question about the value of each individual Bitcoin. For example, they're supposed to be fungible, but my speculation is that the value of the Bitcoin, that let's say if someone goes with Gorilla Pool and they get fresh Bitcoin, it doesn't have any taint of maybe having been from Mt. Gox or whatever.
Sure.
So are you able to talk about what the value potential might be for freshly mined BSV directly from Gorilla Pool versus if you own something from 5-10 years ago? And can you talk about that?
Sure. So I didn't even really talk about our hashing operation, but if anybody's interested in mining, if you want to have like an infrastructural part in Gorilla Pool, you can buy miners. We're a public pool. You can mine virgin coins. So we don't have a side pot and just pay you other coins. You literally get the block reward. So if you've got a thing for virgins, there's one good way to get them. And but the cool thing is that to Michael's point, Tim Draper markets the fact that he bought Ross Ulbricht's coins, and he thinks they're more valuable because they are Silk Road coins. Part of the value prop is that they have a cool history. I'm actually a coin collector. I've been a member of the American Numismatic Society. I've seen inside the vault in New York City at ANS. So I've seen 5,000-year-old coins from all over the world. I've seen Viking money used to buy ships between famous Vikings. And I have seen J.P. Morgan's personal coin collection. Now, J.P. Morgan at the time was top 3 richest men in the world, and what he was doing is he was buying all the mint proofs. So he bought the first coin off the press for like his whole career, something like 25 years. Every year he'd get the first coins off the mint, and so they were never touched by human hands, and they were his collection. Now the face value of his collection is less than $1,000. That's the fungible value of his stuff. You could go buy a can of Coke and a slice of pizza in New York City with what's in one of these drawers. But because it was J.P. Morgan's, the collection's worth like $25 million. But because they are also untouched, first off the press, serialized mint proofs, I think the collection's worth some absurd. They told me they can't even insure it because the cost to insure the collection it would bankrupt them. It's an irreplaceably valuable piece of history on top of the fact that it's money. Now, Bitcoin's the exact same way. Your individual sats have a known fungible value in commerce, but I think if Ordinals has taught us anything, it's that some sats are worth more than other sats for reasons that may confuse many. But occasionally, you might have a $100,000 single Satoshi in your collection just because the artist who touched it or the person who inscribed it or even the order in which it was inscribed is significant in some way to us crazy people. And so I'm a big believer in mining virgin coins. There's a reason we let people mine them, and I'm trying to give people the opportunity to have access to Bitcoin in the way that people had access to Bitcoin in 2009, 2010, 2011, in that you can mine coins. Like collectively, we have a generally low difficulty network, and you have access to virgin coins that you can say, look, here's the block I mined, these are the coins I minted, they haven't moved, and maybe in 10 years from now when we've conquered the earth, or maybe 22 days from now because the age of Aquarius is coming, you can be the one to say, hey, these are my sats that I mined. They're unmoved, they have no history, they have no taint, and let's make a deal. Kevin.
What are the basic costs to get involved with Gorilla Pool if I did want to have mining and participate?
Super simple. We have accounts with Bitmain and MicroBT, so we can act as your broker to import ASIC miners. You can buy a brand new K Pro Antminer for like $2,000. If you get that, you can take delivery of it if you're an electrical engineer and whatever else, and you want to deal with that in your home. But we also offer hosting both in the United States and Canada. We are filling up our Iowa site right now as we speak. So we would offer you something like a little under 9 cents per kilowatt hour essentially. And so you pay us your electric bill every month, and you get Virgin coins in return. So,
Got it. So
also for anybody who's a business owner, if you're looking for business write-offs, buying ASICs, you can depreciate it using bonus depreciation or section 139. Talk to your accountant about depreciation on computing assets as a company. It's a really good way to limit your tax liabilities.
So in other words, to summarize that, it's $2,000 for the machine, and you're going to get 9 kilowatts per hour paid from it.
9 cents per kilowatt. They're currently profitable.
But if you could find electricity for less than 9 cents a kilowatt hour.
That's currently what we're offering. Yes, okay. is a little less than 9 cents per kilowatt hour. Some people may have the opportunity, but it's not just the price. It's also the deliverability. Like they consume, one ASIC consumes about as much power as a house in a day. So if you are going to run it somewhere, you really need to know what you're doing, or you're causing a fire hazard pretty quickly.
Yeah, because I think in San Diego it's like about 50 cents a kilowatt hour.
Yeah.
And so if I'm going to get 9 cents, it doesn't make sense. But if you could find a different place for energy, in the desert or something. Then,
sure. Well, and that's what we look for. So I mean, we have a person at the company whose job it is to look for old power contracts that want to resell the power that they already own, or a lot of times there's like weird municipal power companies that are in rural areas that just have cheap rates because there's very little demand. We have a tendency to go near the Mississippi River. If you look at where we mine, it's Kansas and Iowa and Illinois, and we're just kind of following the river. Because they get credit for doing both hydroelectric and grid-tied power. So, but we offer that as a service, which is, in some cases 80-90% cheaper than retail power, but it's cheaper than every retail power I've ever heard of in this country. So, yeah.
Thanks.
Yep. Thank you. Amy?
Kurt, thank you so much for your talk. Bringing this back to JungleBus, and some of this, you mentioned cat JPEGs, right?
Yes.
And like bringing it back to this to say, like, okay, and I know I've asked you some of these questions at dinner last night. I was like, okay, I know this is not profitable, but I wish someone would build the search engine for what's on chain. And I know that's definitely not profitable. But then I was wondering for you as JungleBus, like say it's cat videos, or somebody likes dog videos, or somebody likes frogs, or somebody once had Ordinals, but what about the next new thing? So if these are blobs of data, are these tags you have on these? Can it be multi-tags? How are you going to solve the problem of when something new comes out? Are you deciding? Is there a schema, or how does this work? Or we as a community deem what's important?
It's all kind of a both and, actually. So most things, when they're broadcast to the network, will have a data tag as to what they are. So they'll be compliant with like B protocol is a major data protocol that's used. I also had the Magic Attribute Protocol is a way to tag that data. Now, people have been tagging data for years. What JungleBus does is it filters based on those tags first, and then so if you were to build a search engine, your front end could run a lighter index that is then filtering or caching. For example, something new that pops up at the Super Bowl, whatever the biggest ad is, you could sort of pre-cache that data because you can anticipate we're going to get a lot of searches related to this over the next X amount of time, and therefore this is running in cache very, very fast. But then if somebody decides hey, what was the first Omega watch that ever went to the moon? What was that model number? It's not a thing that people are going to search for a lot, and therefore it'll have to dig down databases a little bit. And we see this actually in modern search engines, and there's a famous tweet. what is the tweet that everybody's likes get disappeared from? You can get over your distaste for Craig at $100, $1,000, or $10,000, and everybody has to re-like it like 3 times a year. It's not that they're re-liking it. It's because the cache is not tracking all of those likes, because Twitter or X doesn't have an incentive to just constantly be throwing compute at let's make sure Ruth's tweet is accurately clicked. But if you were to open that tweet and leave it in a tab for 2 minutes, 10 minutes, an hour, or whatever, it would probably catch up eventually and display properly. But nobody's doing that kind of forensics on the tweet. So every database works this way. If your data isn't critical and it isn't being paid for and it isn't being asked to be put into cache, it just gets buried lower and lower and lower until somebody calls it back up, and then it starts to make its way back down again. So JungleBus is like the shovel for digging for data that you need. So build that search engine and use JungleBus for it, please.
Cool, thanks.
Yep.
Thanks, Andy. Kurt, you mentioned, this is Gavin, thanks, good to see you, buddy. And
you too.
You mentioned about these, you have a contract with Bitmain. It seems like there's a difficulty for just a regular consumer to get a contract with Bitmain. I mean, say, well, why can't, I don't know if anyone's looked into it, but it seems to be a little bit challenging. So what is the the scarcity or the resale value, secondhand value of those rigs, for somebody that gets involved in the mining with Gorilla Pool, and how does that play out?
So, I mean, the world is getting smaller. Your Alibabas and DHgate and some of these places where you can go buy stuff direct from China has made it seem a lot simpler. But an ASIC is a highly specialized piece of equipment. And the way that you have to ship it actually has all kinds of regulatory stuff, because technically it is a Chinese computer, and shipping it into the U.S. has some regulatory issues, especially post-Trump presidency. So you kind of have to have pre-sorted some of your import logistics in order to say, yes, we're allowed to ship in pallets of Chinese computers whenever we want. We promise there's nothing suspicious going on. But Bitmain will definitely take your money as hey, can I buy one? Yeah, sure. And then it has a tendency to just not ship and not ship and not ship. And then you get a way bill and it still doesn't ship. And then when it arrives, customs is trying to figure out why you're importing Chinese computers. So that's part of the service we offer in just having an account and having U.S. supply too. We also just kind of slowly refill our supply so our warehouse doesn't get empty, which is why we're able to typically deliver in 2 or 3 weeks from the time you purchase. If you were getting it from China, it would be 60 to 90 days at best, because they're going to ship it the cheapest, slowest way they can to save money. Now, from an ROI standpoint, ASICs are still really cheap right now relative to the price of Bitcoin, even though BTC is at all-time high again. Last time BTC was at these prices, used miners were $10,000 a piece for a 90 terahash machine. And today, you can buy an S21, which is a 200 so more than twice as efficient machine, and you can buy that thing for $4,000. So the reason for that is because difficulty is really high, and so the ROI, the perceived ROI on the machine is long. But this is why it's more profitable to mine BSV right now. Is BSV's price to difficulty ratio is actually a little bit out of balance right now. So if you were to just sell every coin that you mine on both chains right now and mine both chains, you'd be making more dollars mining BSV today, because it's just about that. The reason is pretty complex macroeconomic stuff, but your marathons and riots and all this stuff make a lot of money on power curtailment deals and selling very overvalued stock. So they kind of don't have to make money mining Bitcoin. And so they just keep deploying ASICs and keep driving the difficulty up past where it would be profitable to mine BTC, making it that small people really, really struggle to ever ROI on BTC right now. But in BSV, if you're doing it for dollars, you have a bigger opportunity. Now, that number will shift. I guarantee my haters will post it's 3% more profitable to mine BTC right now. And it's yeah, but check again in an hour and a half, and it will be different again. And that's how difficulty works. It's a very complex algorithm to figure out profitability. But if that machine looks like it could ROI in 3 months instead of 12 months or 18 months, well, then that ASIC is also going to be that much more valuable. So what we've seen in the past, and we've done this 2 cycles straight, is you buy ASICs when nobody, it's the same as the logic for buying Bitcoin. When the price seems too low and like it'll never pay off and you're an idiot, buy more ASICs, because the ASIC also goes up in value as its perceived ability to ROI goes up. So you might be able to buy an ASIC for $2,000 today and sell it for $10,000 in 12 or 18 months. So that's the opportunity on just the hardware. And if that's the case, your coins have also gone up in value. But for the BSV investor, that's also the hedging opportunity too. So if BSV just never outperforms BTC as a percentage or in dollars or whatever else, well, it's a SHA-256 ASIC. You can sell this to some BTC, you can sell your ASIC to a BTC person at some point in the future, and you still made money on the ASIC itself, even if the BSV didn't end up being a good investment opportunity.
So it sounds like there's a more likely than not that if you are patient enough, then the ASICs would actually go up in value from the price that you paid for them?
Yes. It's like buying real estate.
Thank you.
Yep.
Hello, Kurt.
Hello, Brett.
Thank you for your presentation. This is Brett Banfi. We're at a hackathon, so I want to get people thinking about what to build in the future. And specifically, one thing that I want to touch on is some of what David was talking about yesterday. If we just think about authentication for the internet, a lot of times that authentication, we just think like, HTTPS or something like this. We're using this certificate or certification of the validity of information, but it's oftentimes coming from a trusted network or from a trusted partner. Mm-hmm. Can you talk a little bit? You oftentimes refer to your vision as a Bitcoin ISP, and some of it sounded like what David was explaining is the ability to maybe replace things or to put DNS onto, instead of using this trusted partner to verify this information. Using this, the authentication, the innate authentication services that Bitcoin provides us. And so could you talk for the viewing audience, especially those who are interested in building some of this stuff, what does that enable, and specifically maybe also within the context of how sCrypt can help to enable that?
Yeah, I mean, it's a broad question. There's a lot of ways to answer it, but actually every blockchain has an indexing problem. BSV gets criticized for the network's not performing well, but I know these guys will tell you hey, the BTC ordinal stuff is why is everything out of sync again? There's a lot of problems across chains. You got this on Litecoin and Doge and other things too. So actually JungleBus could work with some re-engineering, a little bit of re-engineering. It could work on these other chains too and also solve their indexing problems, because again, they're also trying to run an indexer directly connected to that node, and they're starting with just a gobbledygook chunk of data. Now, it's easier when it's only 1 megabyte every 10 minutes of gobbledygook data, but it's still gobbledygook data that needs specialized processing for decent service. So for me, the way I see any kind of authentication or DNS, it's a data availability problem. It's the same as trying to launch a company like Netflix in 1995 would have been impossible, which is why they're well, we can mail discs, and the most powerful network in the world is the U.S. Postal Service, and so that was the network that they had their limitations on, and so they built a business model around it until the internet became a better vector for that. As the internet improved in its ability to process data and serve data, then it changes that whole model. And so that's what we're trying to do. We're trying to build tools to go from your SBC Global or Ameritech dial-up to whatever it is now, your Verizons and Xfinity cable internet speeds and stuff. But it's the tooling. You need the infrastructure, the tooling, the application, but you need demand too. It's literally build the economy as you want to see it. So all of those ideas, your BitDNS sort of stuff, all of that are things that work a whole lot better when there's a lot more connectivity, and we're just trying to build the connectivity and the processing power. We see infrastructure as the way to make all of you our customer, and then we let you be creative on how you use the flow of data we're offering to you. What's up, Raph?
What's up? Thank you. Thank you for being here, Kurt. So my question is, what are your thoughts on flipbtc.xyz?
So I've only overheard its discussion last night. You want to clarify?
Can you pull it up on the computer?
Difficulty. This isn't my computer, and I don't know where to go.
Can someone pull it up on that computer real quick, so that everyone can see the? Not easy.
No, OBS and streaming.
Okay.
Tell me about it. What's
lock
to flip is the.
I mean, I think it's we're calling it's a difficulty options locking, and it's for all the finance people here, it's a binary options trade around hash power difficulty between BTC and BSV. I think is there anyone here that thinks that's not the proper way to define this?
It's clear as I understand it.
I love that. Well, someone just said TradFi 2.0. I love that. Yes, it is. I guess we would say that the base trading pair is difficulty. Hash power SHA-256 traded between BSV and BTC. I think everyone, I'm looking around, I think everybody agrees am I defining this right? It's crazy because these are new concepts and we're kind of like.
Yeah.
So what's your thought on that? Do you have any, what comes to mind?
I think it's awesome. So when I first heard about difficulty locking, because difficulty is a pretty good proxy for determining overall price or value, I like the idea of being able to hand somebody coins and saying, these are yours, but they will only become usably yours after we've achieved a certain amount of value. I think that...
Have you seen the site?
No, I haven't.
Here.
I've literally overheard it.
Just take a peek real quick. I want to see what I want to get your feedback on it real quick.
So what I love about it is the concept of gamifying our victory. Like we're turning this into something fun, and giving it a goal. Like what is the goal? Is it price? Is it whatever? Like it doesn't need to be price if we also have volume or whatever. But it's about the profitability of operating the network as a proxy for victory.
Create option at the top.
Create option. Click it. Should I click it?
Yeah, go
Raph,
for it.
I don't want to spend your money. I don't know if you're logged.
Yeah, it's okay.
So you can sleep on my couch.
I saw it. Yeah.
No, it's cool. I really like everything about the lock stuff. So I like this blocks until expiry, the flip it ratio. Imagine even getting to 1%. Like imagine if we create a pot and say, okay, all these BSV are in this pot, and when we get to the 1% ratio, the pot's spendable and we'll throw a party somewhere, right?
Yeah.
We'll have a celebration party for when we get to 1% of BTC.
Hey, that's a great idea.
But you can sell these on this marketplace, and it makes it basically a derivative.
There you go.
I'm sorry, can you please repeat that?
You can create these options and then sell them, so you can get premiums on writing call options, basically.
Sure. I'm for creating secondary and tertiary market opportunities anywhere people want to trade. So, no, it's cool. Super cool.
Degen TradFi 2.0.
I'm
okay.
all for it. Thanks, Rat. All right, so I think I've been up here for close to an hour, perhaps. Anything else?
Why don't you offer that as a service for what Virgin coin?
Oh, snap.
Oh, mine Virgin coins into the pot.
Boom, boom, boom.
There you go. So
boom, boom.
If you want to talk about any of this, like I've actually talked about kind of a lot of business opportunities. I didn't intend for this to be a sales presentation, but but I will take your money. But no, just talk to me if you're interested. I'm Wuckert Jr. You can follow me everywhere, and feel free to DM or talk here in person. We can talk about the various opportunities. Just text me, bro.
Ty, before we go back to you, we're going to do a photo out front, outside of this little pavilion area on the thing around 11:15. So back to Ty. Cool. Thank you.
You might have you left it on.
Yeah, you're right. Ty, why don't we do the photo now?
Top right.
He wants to announce it.
Or you're right, sorry, top right.
Hey, Ty, can you announce a quick break and then
Yeah.
we'll do a photo?
All right, everybody. So, thank you for tuning in for the streaming audience. These were some great presentations by Kurt Wuckert, as well as earlier Jake Jones of Teranode. And so we're going to break for lunch here. The stream audience, we're going to be coming back at 1 p.m. Pacific, or just before that you can start to tune in. And so there's going to be a 2-hour break for lunch. And so yeah, thank you to the streaming audience, and for the live audience, I have some announcements after we end the stream. All right, everybody. Let me